Hi, we would like to show you today a quick demo of our application Hypercode that won OpenAI Codex Hackathon in San Francisco. Hypercode is a layer between repository and coding agent. It replaces grep-based searches with simple tool designed to retrieve context-aware groups of files ranked with relevancy score to the user query. That means that using our tool within Codex makes it work faster, it saves context. As a consequence, costs are reduced. We don't miss files relevant to user queries. And we also already at the beginning find relevant memory traces from Codex sessions that might influence following agent decisions. When we tested our approach in Codex, our plugin execution was over 50% faster. We reduced number of used tokens. We found all relevant files, even if these were not statically linked, and we discovered all potentially affected files with the change. And this is already a huge improvement compared to the standard Codex sessions that have to iterate multiple times and look to find relevant files in the repository and still often miss some connections. Our approach was built on 3 pillars: structural links, symbols, and commit diff code change, describing connections between files. This is already what many IDEs does in the background. The second pillar were summaries and feature labels describing cluster of changes, extended initially statically linked files, enabled one-shot semantic search over the repository. And finally, we enrich our final index with Codex memory session informations so that previous decisions can influence new implementations. This creates a hypergraph structure that is the heart of our solution. And now Max will show how it looks like on real-world repository and queries.
All right, so our demo consists of 2 layers. First of all, we got a visualization layer when we'll show you the graph. And then I will show you the Codex with our plugin installed. So first of all, you can see this graph. This is a graph of all those connections between different files. We can also take a look at clusters that were auto-created by our algorithm. And you can see in different clusters, we got different files connected with each other. Those features are auto-created. They are not assigned by us. Then we got sessions. Sessions are the actual Codex sessions where we build our solutions, our features. We can see that, again, files are connected in between different Codex sessions, and also some decisions were made just like that. So those decisions are then persisted and saved in our graph. Then we can take a look at a different query search, and as you can see here, different files are highlighted, different connections are highlighted, and then also we can see the results in detail. You can see all the relevant files right there. So first of all, we got the relevant Codex sessions and also the decisions behind those Codex sessions, and then we got the files. So we got 3 categories: primary files, support files for to review, and also likely affected. You can see that all of those have some relevancy score right there. Okay, so the second part of our demo is about Codex and our plugin integration. Let's take a look at this now. To install our plugin, it's super simple. We created a local marketplace where you can basically install Hypercode directly. And now our Hypercode is installed. So let's go to the repo and let's paste the previous query. You saw this query in the graph before. So let's work in plan mode because we want to create a plan first. And let's execute. You can see here that in our plugin, we have hooks, 2 hooks. First of all, we will start some coding session with Hypercode. And then after our prompt is submitted, we added some context. This is the whole purpose of Hypercode, to add the context at the beginning so that we'll not need to search those files later. You can see that the context here is all about decisions, all about files affected in the context already. All right, so let's take a look. You can see here he's thinking and planning what to do. And an interesting thing is that we are not grepping, we are not searching. You can see here that we are exploring files, but not searching for any queries directly. So it assumes that we got everything prepared by Hypercode, which is, I think, great. But if there is a need for additional search and it will decide that there's a need, then it's not a problem because it will search by itself. All right, and as you can see here, as the output, we got the plan for PostgreSQL migration ready for you. Yeah, thanks guys, and I hope you enjoyed our demo. And yeah, take care.